Okay, so the next type of reaction we're moving on to is redox reactions. Now, redox is more used in inorganic chemistry, but it does have a place in organic chemistry. When you do inorganic later in the year, you'll be talking about metals and moving from one oxidation state to another. And that's when we talk about it being about electrons. But here it's just about the movement of hydrogen and oxygen, which is generally opposite. So, with redox, there are two things you can use to remember it. Oil rig, so oxidation is loss, rig being reduction is gain. Or this one, Leo the line says GR, so loss of electrons is oxidation, gain of electrons is reduction. I prefer this one because it tells me what is being lost and what is being gained, and even though electrons don't really play a role in what we're going to talk about, electrons and hydrogen always do the same thing, so we can remember that easily. Over here, it's up to you to remember what's being lost in oxidation and what's being gained in reduction. So, as I said, hydrogen and electrons do the same thing and oxygen does the opposite. So oxidation is a gain of oxygen and a loss of hydrogen and electrons, and reduction is a loss of oxygen and a gain of hydrogen and electrons. I suppose that's relatively easy to remember because oxidation is a gain of oxygen, which makes sense. So down here, I'll show you how you can move between our functional groups. So we start with an alkane here and we move to an alcohol. It has become oxidized because we now have an OH group. We have an oxygen we didn't have before. This is then oxidized further to an aldehyde, even less hydrogen, over to a carboxylic acid, more oxygen, and all the way through to carbon dioxide, which doesn't have any hydrogen. So this pathway is oxidation, but of course there is the reverse, which is reduction. So as we move through this way on our oxidation pathway, you have a gain of oxygen each step or a loss of hydrogen, sometimes both. And when you go this way, you've got a loss of oxygen. We're going back to more hydrogen each time. So a gain of hydrogen. And we don't really need to worry about electrons, but you'll understand that later in the year. So we can also use oxidation reduction to talk about how we move between the hydrocarbons. So here I have an alkyne. I can write that there. I can fit that in and you can see it. And here we have an alkene. And here we have an alkane. So each step we've taken, it has gained hydrogens. So in this one we had 2 hydrogen. This one we have 4 hydrogen. And this one we have 6 hydrogen. So we refer back up to here, and a gain of hydrogen here would be reduction. So that has been reduced. And then if we move the other way, it would become oxidized. So that's all we really need to cover for redox. It's a way of you in your exam to be able to justify your reactions. If you see that something has gained oxygen and lost hydrogen, you can say oxidation has occurred, or the opposite, reduction has occurred. Reduction is also referred to as hydrogenation for obvious reasons. You're gaining more hydrogen each time. I know in the chapter reviews for the red textbook, they ask you what is the same as hydrogenation, and that would be reduction.